Hey, you're running through a vast field at night, as if something is chasing you right now. The light of the full moon brightens your path, and you see a circle of light around it. You run on looking for a safe shelter. It's not about werewolves, who are said to appear when the moon is full. Soon, this place will be the epicenter of a major storm. This very circle around the moon is called a halo, and ice crystals cause it in the sky. When the moon is full, it reflects a lot of sunlight. These rays then pass to the Earth's surface, but they curve their trajectory and split as they pass through hexagonal ice crystals. As a result, we have a halo of different colors, almost like a rainbow. The inner edge of the halo is red and the outer edge is blue. It looks beautiful, but the presence of ice in the clouds means this ice will soon turn into water and begin to fall to the ground. And this rain will be so heavy that you'd better find a shelter beforehand. If the weather is quite warm and the clouds are closer to the ground, you might see a similar phenomenon, a corona. It's much smaller than a halo, but much more colorful. The bluish-white disk on the inside turns brownish-red on the outside. Unlike halo, the corona is made of water droplets. The smaller these drops are, the larger the corona will be. If the water droplets are large, the corona will look like a bright spot the size of the moon itself. Both the corona and halo might also occur during the day when the sun is shining. But be sure to wear sunglasses before just glancing at it, because it's very bright and really bad for your eyes. As soon as you find a shelter, it starts raining heavily. Whoa, what is that? Are you being photographed? No, the flash you just saw is lightning. Bam! Thunder is so strong, the windows in the house start to shake. Here's a tip on how to tell if you're far away from the epicenter of a thunderstorm. When you see lightning, start counting. 1 1,000, 2 1,000, 3, and so on. When you hear the thunder, stop counting. Now you have to divide that number by 5. If you can count to 5, it means the epicenter of the thunderstorm is 1 mile away. If you didn't find a shelter before the thunderstorm started and it caught you in the open, leave the high ground immediately. Any mountain or hill is a high-risk area. Don't even think about hiding under a tree. Tall objects are the first target for lightning. Power poles are also at risk. If a thunderstorm catches you riding a bike, drop it immediately and run away. Same if you were riding in a convertible, golf cart, or motorcycle. If a thunderstorm started while you were in an open field, the tallest object here is you. Get down and try to cover yourself somehow. If you're not alone, try to keep your distance from each other. Whew! Now let's admire the beautiful sunrise. It looks like someone spilled red paint on the sky. This beautiful view means it's about to start raining. You can see a red sky at sunrise because the high-pressure zone has just passed you by and is now followed by a low-pressure zone with high water content in the air. So take an umbrella with you or go back to a warm bed and stay indoors. There's an old saying to keep it all straight. Red sky in the morning, sailor take warning. Red sky at night, sailor's delight. Sometimes you can even predict rain by smelling it. It's all about ozone molecules. Storm currents bring ozone down from the upper atmosphere, and when the storm is about to start, you can smell a sense of cleanliness. It's like you just washed the floor with clean water. Your sense of smell gets more sensitive before it starts to rain. It's not because of your nose, but because of the more humid air. Flowers spray their scent, and the water molecules stick to it, spreading it much better. That's why the same flowers smell different when you smell them outside or in a closed, humid greenhouse. Plants can also help you predict changes in weather. If you touch the grass in the morning and it's wet, it means it's going to be a clear day. That morning water on the grass is dew. It appears at the coldest time of night. Clear skies allow the earth to cool a bit, and the water vapor molecules in the air turn into a liquid that settles on various surfaces. Take a closer look at the leaves on the trees. Sometimes they can be upside down. For example, maple leaves respond well to increased humidity before the rain. Their stems become very soft, and the wind can turn them upside down. But the best indicator is pine cones. The seeds are inside the cone, just under its scales. The pine needs to keep them as dry as possible so that the wind can carry the seeds far away and new trees can emerge from them. So, when the pine senses rain approaching, it gives the order to close the cones. Then the scales close, protecting the seeds from the water. And instead of boring weather forecast hosts, you can just follow the animals and insects. Have you heard the crickets chirp? That will be your thermometer for today. Set the timer for 15 seconds and count how many times crickets chirp. Add 37 to that number and you get the outdoor temperature value in Fahrenheit degrees. All because air temperature directly affects crickets' metabolism. It can chirp slower and faster depending on how warm it is. So throw away your thermometer and get yourself a little friend. Now, if you don't like insects, look up into the sky for birds. If they're flying high, it'll be a clear and sunny day. But before it rains, air pressure prevents birds from flying high. You may see them flying in flocks very low, most likely looking for shelter. So even if the sky is clear, air pressure tells you that rain is coming. If you live near a river or lake, you can hear toads singing, although you can't quite make out the lyrics because it's in toad. They are especially loud before it rains hard. Toads, in general, love wet weather, so they just get excited. Rain is also the best time for females to lay eggs, so they scream loudly in search of a guy to wed. Ow! A mosquito has just bitten you. If mosquitoes are being especially aggressive, you better find a shelter fast. The insects are just trying to eat more before they have to starve during the storm. Also, the warm, humid air makes us sweat more, and we become even more attractive to mosquitoes. Insects also gather in swarms before a thunderstorm. They love the moisture in the air and start circling in a dance. But then they vanish into thin air. It means you have 1 hour left before heavy rain starts. To predict the weather for the next day, you need to watch the bees. If it rains tomorrow, the bees work overtime. They're pollinating flowers actively because they know they won't be able to leave the hive the next day because of the rain. Squirrels can predict the weather for the whole season. They usually stock up on food for the cold times. And if they start doing it early, it's going to be a tough winter. You can see squirrels running around looking for acorns. They hide them in the ground and run to find the next one. The squirrels often forget where they hid their food. These acorns turn into little sprouts, so we have many new trees, all thanks to squirrels. Animals can also predict disasters like earthquakes. Scientists once did a study in an area with frequent earthquakes in Europe. They put trackers on cows, dogs, and sheep. About 18,000 earthquakes occurred there during that time. Most of them were insignificant, but there were also 12 with a magnitude of 4 on the Richter scale. And each time, before the earthquakes, researchers recorded strange animal behavior. It was as if they were trying to escape from the earthquake zone. Scientists believe animals can sense the ionization of the air before a disaster with their fur. Their good sense of smell also allows them to smell gas. It comes from moving deep underground and then trying to find its way out through small cracks in the surface. The first records of such animal behavior date back to ancient Greece. Cats, rats, snakes, and centipedes left their homes and fled to safety days before a major earthquake hit Greece. Some fish can predict the weather in the area. If sharks hang out near the shore, they're not necessarily looking for food. They may be hiding from a big storm at sea. The worst sign on the coastline is when all the water starts to go back abruptly. You can see the entire shoreline and even the fish and coral that are left on the land. Run away immediately, because soon a huge tsunami wave will come here and wash everything away.
When lightning flashes across the sky, it releases somewhere around 300 million volts, or the equivalent to power 25 million car batteries. Some say you're more likely to be zapped by lightning in your lifetime than to win the lottery. And statistics seem to prove this urban myth, as each year around 28 US locals do get electrically charged from the sky. The world's infrastructure can be affected by lightning too. That's because it generally seeks out the tallest structure around. But in certain conditions, it can also strike an open field. So scientists came together and invented a laser lightning rod that might help. This unique invention might make lightning strikes a bit more manageable, since it can guard a much larger area than the traditional one, and it's flexible. Classic lightning rods work like magnets for that powerful electrical charge. There are these tall metal devices placed on top of buildings. When a storm approaches, the rod provides an easy path for lightning to follow, preventing it from hitting other parts of the structure. The rod is also connected to the ground with a conductor, like a wire, helping the electrical charge to safely make its way into the earth. This process protects the building and the humans in it by directing the electrical energy away. We've been using lightning rods for the last 300 years, courtesy of Benjamin Franklin. But they're not damage-proof. When it comes to safeguarding vast spaces like airports, they can't manage. That's because they can only cover an area proportional to their height. Here's where this new, improved lightning rod can help. When the laser zaps the sky, it leaves behind a trail of superheated air called plasma. The same way a sculptor carves out traces in clay, the laser creates channels in the air. These channels then become the lightning's new favorite route, guiding it down to the ground. This new method was tested in the Swiss Alps back in 2021, and the results were promising. These lasers do have their own disadvantages. They aren't always available and need a heads up. That's because they have to be activated before a bolt hits. If you're a second too late, tough luck. Also, once the laser stops, the air loses its conductivity pretty quickly. This means the laser rod might not have enough power to guide the lightning safely. A potential solution might be monitoring the electric field around a certain area, predicting where lightning might strike. Yet, these new rods still need more testing and lots of funds. The European Space Agency found another way to make lasers useful: to turn moon dust into roads. It would make our future lunar exploration missions much easier if a laser beam could do the hard jobs, allowing astronauts to drive around the moon. This discovery might also help with another tricky issue: moon dust clinging to everything in sight. Roads on the moon might seem too much of a hustle for now, since we haven't been to our satellite since 1972. But when future space explorers will touch down again, they don't just plan to walk small distances. It'll be nice to have them driving around so they can explore larger areas. Problem is, that pesky moon dust is very fine, abrasive, and sticky. Back during the Apollo missions, it clogged up equipment, eroded spacesuits, and even caused a lunar rover to overheat. That's why scientists want to zap simulated moon dirt with a laser. This laser-powered project used a 12-kilowatt laser to melt simulated moon dirt into a solid, glassy surface, perfect for moon roads. The plan isn't to send a huge laser on the moon. This device they're testing here on Earth is like a stand-in for the sun, mimicking what lunar sunlight could do. The idea is to eventually concentrate sunlight using a big lens on the moon's surface. Some experiments have been done so far with different laser sizes, finding that a bigger beam made the whole process go smoother. Instead of dealing with tiny molten balls, they got a stable layer of molten moon dirt that's easier to work with. What they got was a glassy, somewhat brittle material that can handle downward forces. And even if it cracks, it's fixable. The laser beam was used to make triangle-shaped road parts that fit together like puzzle pieces, forming solid surfaces across lunar soil. If this goes as planned, we'll have moon roads made of interlocked triangles. This unique type of moon pavement could be the solution for landing pads too. Lasers can help piece together information on long-lost civilizations too. Discovering Maya cities has always been difficult for researchers exploring Mexico's Yucatan Peninsula. For years, experts believed no early civilization could have thrived in that harsh environment. But advancements like light mapping technology and laser scans are showing us this might not be true. LiDAR technology can lend a helping hand for archaeologists, especially in areas that are hard to physically reach. That's because it's like we're equipping computers with a pair of eyes. The whole thing works as a flashlight, sending out small light beams in the form of a pulsated laser. These beams bounce off objects like trees and buildings and come back to the flashlight. LiDAR measures how long it takes for the light to return, creating a map of the surroundings. When a self-driving car or robot wants to know where it is, it uses LiDAR to send out these light beams. By figuring out how long they take to come back and where they hit, the car or robot can understand what's around it, making it safer for them to move around through the fog or at nighttime without bumping into things. With this technology, a team uncovered the massive Maya city of Akomtun. LiDAR technology helped researchers to map the jungle floor, revealing hidden structures. Yet someone still needed to verify these findings on foot. The journey to Akomtun wasn't extremely challenging. The region, quite far from the nearest airport, is mostly unexplored, accessible only through old hunting and logging routes. The dense terrain made the trek challenging, taking the team up to 2 weeks to cover just 30 miles. But the effort paid off, revealing monumental structures like a large acropolis and intriguing shapes hinting at a marketplace or cultural center. LiDAR is also used in rovers we'll need to explore other planets. This will allow the robots we send up there to navigate their surroundings without direct human indications. It's also helped us better understand the best location to place solar panels, making it cheaper and faster for us to meet our energy needs. We might also be able to use lasers to predict how a volcano is gonna act. These structures are loaded with magma, the molten rock sneaking upwards from the Earth's insides. When a volcano blows its top, a chemical reaction happens, transforming magma into what we call lava. The specialists behind this new use of lasers think of magma as the computer code of volcanoes. It reveals information on how a volcano might pop up. That's because not all eruptions bring lava, and even if they do, there are different lava types, depending on how runny it is. Magma is like a mix of liquid, gas, and crystals that are shaken up inside the volcano. There are many elements at play before a volcanic eruption, so it's hard to study and understand that complex chemistry. To organize things around a bit, scientists hit the cooled magma, the rock matrix, with a laser, just like the ones you might have encountered if you've ever had eye surgery. It makes the chemical components easier to study. This latest laser eye method was used on samples from a 2021 eruption, which lasted 85 days. It covered over 4 square miles, spewing loads of lava that wrecked over 1,000 homes and displaced over 7,000 people. To prevent such events from happening again, scientists need more data. It's true, earthquakes and ground shifts help specialists predict what a volcano might do, but knowing a bit more about its chemistry can help a bit more. In January 2022, a volcano eruption happened in the Tonga Islands that forever changed the way we understand GPS signals. This volcano caused a massive disturbance, sending out a colossal mix of gas and debris in the air. It generated a shockwave that traveled across the entire atmosphere, reaching all the way to Alaska, and launched a tsunami over nearby islands. Over northern Australia, it crafted a weird plasma bubble in the upper atmosphere, which disrupted GPS systems for hours. People that happened to be under this bubble and in need of precise GPS waited for ages before their device could receive precious information again. The exact place where these disturbances occurred is called the ionosphere. It's the place where our atmosphere meets outer space and looks like this buzzing layer where heat from the sun turns gases into electrically charged particles. It can also be seriously unpredictable, changing depending on the weather and thinning out when the sun's rays are less powerful. Because it's electrically charged, the ionosphere helps us with our communication needs. It houses many satellites, including the International Space Station. Here's how changes in the ionosphere can interact with GPS signals. Let's say you're playing detective with your friends and need to find them using a special radar. This radar sends out invisible waves through the ionosphere to locate your buddies. If everything is normal, you'll find their precise location in no time. Should those waves go through a place where the ionosphere particles are a bit messed up, the waves might slow down, get scattered, or change direction, confusing your radar. In the same way, when GPS signals travel through a damaged ionosphere, they can malfunction. Scientists have developed a way to fix this, like special sensors to anticipate changes in the atmosphere. The ionosphere is also sensitive to rockets being launched from Earth. not just storms and volcanoes. At first, astronomers believed these red patches they were noticing in the sky were similar to the northern lights found in Sweden, Finland, or Canada. But they soon figured out there were gaps in the ionosphere. Beautiful to look at, yes, but experts are worried that these crimson areas might be causing communication and astronomy problems that we've yet to discover. Since scientists don't know all the effects of these holes on our environment, it's best to steer clear if you see a red hole in the sky, just to be safe. But at least they seal up within 10 to 20 minutes. Mars has its own eerie set of lights happening in the atmosphere, and you'd think, since it's the red planet, these lights would also be red. Should you ever land on its surface, surprise! At times, the sky turns to a green glow. This unexpected hue could be very important for future Mars trips, since it can help specialists better understand the Martian atmosphere. Or what's left of it. That's because at some point in its history, Mars switched from being a warm and wet world to the cold, dry plains we know today. How is Mars slowly losing even what's left of its atmosphere? One popular theory is that Mars's weak gravity, combined with the fact that it doesn't have a strong magnetic field, lets the atmosphere escape into space. This vulnerability comes from the solar wind, a constant flow of particles from the sun. The sun's push over millions of years may have thinned out the atmosphere, grabbing the lighter parts. Some scientists suggest another possibility. A colossal impact by another object might have swiped Mars's atmosphere away. Studying this greenish glow is key to understanding what's going on the Martian atmosphere, a place satellites can't directly explore. Since we plan to visit this neighboring planet in the following decades, scientists intend to develop the perfect spacecraft. Knowing its atmospheric density helps us build machines tough enough to handle Martian drag, and we can design parachutes that gracefully descend to the Martian surface. See these amazing purples and greens lighting up the sky? That's not your typical aurora. It's Steve. First discovered by regular people, not scientists, some years back. We now know it's the aurora's more elusive cousin. Steve is short for Strong Thermal Emission Velocity Enhancement and was caught on camera back in 2018 by a bunch of amateur aurora chasers in Canada. They then brought it to the attention of NASA scientists. Here's how this is different from the aurora, starting with the appearance. Steve is more of a magenta streak, while the aurora is usually made out of green ribbons. Auroras happen when particles from the sun interact with the Earth's magnetic field and atmosphere, causing gases to emit light. Steve is thought to be a separate optical phenomenon that sometimes appears alongside auroras. While the exact mechanism behind it is still being studied, scientists believe it is linked with charged particles in the ionosphere that also interact with the Earth's magnetic field. Now that we know where to look, Steve might not be as rare. If you're planning to catch a glimpse of it, you'll need to travel to places where auroras usually happen, like Canada, Alaska, Northern Europe, New Zealand, and Australia. That's because it's never visible on its own. It's powered up when the aurora is extra bright during geomagnetic storms. Auroras can also happen on the sun too. These luxurious lights happen somewhere around 25,000 miles above a sunspot, a dark magnetic patch on the sun's surface. Astronomers have only recently discovered our own sun is capable of generating these lights. So far, they've only spotted aurora-like signals from faraway stars. Here on Earth, the aurora can last anywhere from 15 to 30 minutes, maybe even a couple of hours if you're lucky. On the surface of the sun, though, this phenomenon is a week-long display of intricate lights. Strange lights in the sky can also happen before an earthquake hits. Mexico had its share in 2017, lighting up the internet with pictures of weird celestial shades before a massive magnitude 8.1 earthquake. Some voices in the scientific community wonder if this light phenomenon is indeed connected to earthquakes at all. Others have this theory that such lights are caused by the release of ionized oxygen from the breaking of certain rocks. A photographer from Finland captured these shots of a circular rainbow display in the sky and wondered what might be causing it. It's something pretty ordinary: pollen. These colorful rings are called pollen coronas, and they happen when sunlight hits the pollen in the air at a certain angle. You can easily tell if you're looking at pollen coronas if they're accompanied by star-like sparkles. Those are individual pollen grains, and they come in many sizes. The process is very simple. Sunlight hits the pollen and scatters into different colors. Some colors get blocked or crash into each other, creating a pattern known as diffraction. The pollen in these images is from pine trees, and under a microscope, they look like tiny Mickey Mouses. Those ears are actually air pockets that help them float in the wind. The air sacs all line up in the same direction, creating the elliptical shape of the rings. For these coronas to show up, pollen levels need to be very high. An astronaut up on the International Space Station once snapped this picture of our planet, showing these two weird blue patches of light in our atmosphere. They might seem related to each other, but these lights are two different natural phenomena that just happen to be captured at the same time. The first one down at the bottom is a massive lightning strike that zapped somewhere in the Gulf of Thailand. Lightning is usually pretty hard to spot from way up there because of clouds, but this time it struck between them, firing up the walls around it like a luminous ring. The second blue blob up in the top right happened because of the moon. The way our natural satellite lines up with the space station lets the sunlight it reflects shoot straight through Earth's atmosphere. This turns it into a bright light with a fuzzy halo. It happens because some of the moonlight bounces off tiny particles in our atmosphere, making the moon look blue in this picture. That orange halo curving along Earth's edge is just the atmosphere.
Hey, do you believe in folklore telltale signs that can help predict the weather? Actually, many of them even have a scientific backup. So let's dive in. You've probably heard this one at least once. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. Oh, you haven't? Then you might have heard a variation with the word shepherd instead of sailor. This weather lore was even commemorated by William Shakespeare, I call him Bill, back in 1593. He wrote a poem, Venus and Adonis, and there is a description of the red sky lore. Turns out Bill was right, and this one can be explained. The red sky appears when dust and small particles are trapped in the atmosphere by high pressure. When sunlight passes through the Earth's atmosphere, it splits into different colors of the spectrum and creates colorful skies. If there's a high-pressure system, it can trap dust and vapor in the atmosphere, causing blue light to scatter and leaving only red. So it can indicate that the weather will be clear and calm the next day, whereas a red sky in the morning can indicate a storm is on the way. How about another one with sailors? Rainbow in the morning gives you fair warning. Rainbow at night is a sailor's delight. Now this suggests that if you see a rainbow in the morning, it means that rain is on the way. However, if you see a rainbow at night, it means that the weather will be calm and clear the following day. And the pot of gold at the end of the rainbow is still a myth. Next one. They say no weather is ill if the wind be still. This one's pretty logical too. Calm weather conditions show us that the pressure is high in this area. Highs are regions of descending air, and they prevent bad weather phenomena, such as clouds and precipitation, from forming. But there's more to that. Actually, calm conditions may be a true sign that bad weather's on the way. We often call it the calm before the storm. Have you ever seen this halo around the sun or moon? Well, it's another telltale weather sign. Next time you spot such a halo, make sure to grab an umbrella before you leave the house. This phenomenon occurs because of refraction. The sun and moon provide light, although in different ways, and this light gets refracted by ice crystals at high altitudes. When you see a halo, it means that the moisture up there is going down. Also, these halos may evolve into another beautiful phenomenon, milk sky. The milk sky is still clear, but the typical blue shade is sort of washed away and appears a bit faded or milky. Today, we can just check the weather forecast on our iPhones. But centuries ago, people needed to have some alternatives to be able to predict the weather. The very first weather forecasts appeared around 650 BCE. Back then, the Babylonians would predict weather using cloud patterns. Ooh, that's a fluffy one. Uh-oh, there's a dark one. We should go inside. People had to wait for quite a lot of centuries for mass weather forecasting. The first prototype of what we have today appeared in 1835, and it was thanks to the invention of the electric telegraph. By the way, back in the olden days, animals contributed a lot to weather forecasting. Some traditions are preserved up to today. For instance, Groundhog Day. Long story short, if the groundhog gets out of its den on the 2nd of February in Punxsutawney, Pennsylvania, and sees its shadow, it will go back into the den, and the winter will last for 6 more weeks. On the contrary, if the groundhog does not see its shadow and doesn't get scared, spring will arrive soon this year. There's no actual scientific backup to this tradition, but surprisingly, in most cases, the groundhog predictions come true. Well, in the US, people get predictions from groundhogs. In Croatia and Serbia, people use bears to see if spring's on the way. On the 15th of February, they watch a bear awaken from winter dormancy. It's all about the shadow again. If the bear gets confused when he sees his shadow, it will go back to its den and sleep for 40 more days, thus prolonging the winter. But if it's cloudy on this day, it's a true sign that spring is coming. As to the poor schmuck who has chosen to wake the bear up, I think I'd pass on that honor. Unlike groundhogs and bears, seagulls can help predict bad weather all year round. They say, "Seagull, seagull, sit on the sand. It's never good weather when you're on the land." These birdies tend to sleep on the water, so if they sense turbulent wind, they prefer not to struggle with it but avoid it. Therefore, they just land on the beach and wait. Smart! Rain before 7, clear by 11. Pretty common, but only partly true. The occurrence of late night and early morning rains may be due to the passing of a weather front. Still, it's not 100% correct to assume that morning rain is a sign that the afternoon will be dry. In some cases, a rainstorm that develops in the late afternoon may last up until the night, causing early morning rain. Now, cows could make good weather forecast reporters too. A cow with its tail to the west makes the weather best. A cow with its tail to the east makes the weather least. Thing is, they don't really enjoy it when the wind is blowing right in their faces, so they prefer to stand with their backs to the wind. Winds blowing from the west usually bring good weather, and those blowing from the east, on the contrary, are likely to provide unsettled weather. Voila! I told you, cows are cool. So, should you ever be in a pasture with cows, you will know what weather it will be in the next few hours, even if there's no coverage and you can't use your phone. Now, in case there are no cows, bears, or any other animals that are sensitive to the weather, you can use onions. Yep, you heard that right. Even onions can predict the weather, and these guys actually predict long-term conditions. Here's a nice rhyme. Onion skins very thin, mild weather coming in. Onion skins thick and tough, coming winter cold and rough. Well, seems there's no prediction connected to French fried onion rings though. If you want to hear a scientific explanation for this, sorry, there won't be any. In fact, scientists say such rhymes have stood the test of time for one reason only, and it's our human selective memory. We tend to remember things we've predicted correctly, and if not, we just forget them. Oaks and maples can be helpful, though, due to their ability to curl leaves when the humidity is very high and the wind's blowing strongly. So, when leaves turn their back, 'tis a sign it's going to rain, turns out to be quite a true saying. There's even a rhyme for it. When the leaves show their undersides, be very sure that rain betides. I know, betides, it's kind of a forced rhyme, but it is a word, it means happens. Okay, time to move on, let's not beat a dead horse. Which, by the way, is not a weather predictor. So hey, did you know that you can even use your friends to predict the weather? Our human body is way more multifunctional than you could have imagined. Here's another short rhyme to prove we humans have superpowers. For instance, our body can predict rain. I know ladies by the score whose hair foretells the storm. Long before it begins to pour, their curls take a drooping form. See? I bet you've noticed it many times and maybe even correlated that our hair may act weirdly when the humidity rises. It may expand in length due to humid air, and naturally curly hair may droop. Naturally straight hair, vice versa, may even curl up a bit. If you have blonde hair, you're even more potent at rain forecasting, as it's more sensitive to humidity. On to more precise predictions. Yeah, it's cool to predict the weather, but what about predicting temperature? You can tell the temperature by counting a cricket's chirps. These guys are quite accurate thermometers. When it's warm, they chirp faster. When it's cold, their chirps get slower. Now, here's what you need to do to get the temperature. Count their chirps for 14 seconds, and then add 40 to the resulting number of chirps. Now comes the disclaimer. Crickets only work in Fahrenheit. For Celsius, you'll need to do some extra calculations. While not all weather lures are accurate all the time, they can be a fun way to predict the weather and connect with nature. Meanwhile, my hair is turning frizzy, so I'll grab an umbrella.
On some nights, when the sky over a powerful thunderstorm is clear, you might see elves, gnomes, trolls, or blue jets. Blue jets sound kinda random here, right? But we're not actually talking about fairy tales. These are all just different types of lightning flashes that are mostly visible very high above raging thunderstorm clouds. Let's take red sprites. Those are flashes of light that appear above thunderstorms that come in clusters. They are rare because they're only caused by a specific type of lightning called positive cloud-to-ground strikes. So a positive charge is transferred from a thundercloud to the ground during a lightning strike. These types of lightning make up only 10% of all lightning strikes. For more than half a century, many believed these flashes were just urban legends. People did see them from time to time, but the flashes were so brief that even if you had been lucky enough to catch them, you wouldn't have had time to call someone to witness this phenomenon with you. Even when respectable scientists or pilots would talk about them, the scientific community would mostly ignore them. In 1989, something strange happened. The researchers from the University of Minnesota actually managed to catch sprites on film, and that's how it started. People across the world began sharing videos and photos of red sprites. Red sprites can start as 328-foot balls made of ionized air. These balls shoot down from heights of about 50 miles at 10% of the speed of light. And researchers have been studying not only the lightning that plunges down from raging clouds, but these colorful flashes that go towards space too. So, electricity stretches up to the electrically charged ionosphere, but at the same time, it crushes down towards the ground. Red sprites come in different shapes, like these big, cool jellyfish sprites that sometimes have areas that measure up to 30 square miles. You may see carrot sprites or column sprites. They're similar, it's just that carrots also have long tendrils. The lower parts of tendrils are often blue, while the higher ones are red. On August 22, 2022, we were able to take some stunning photos of red-white streaks in the sky above the Atacama Desert in Chile. They were surrounded by another bigger glow of greenish color. It's something we call air glow, and you can only see it this well when there's no light pollution. It's basically when we use too much artificial light, and among other things, it doesn't allow us to observe stars and other objects we might otherwise see in the sky. And this airglow happens because of atoms of nitrogen and oxygen in our atmosphere. Sunlight knocks away their electrons during daytime. Then, they slowly recombine with their electrons, which is a process that causes them to glow. How can you see a red sprite? First, you need to find a large thunderstorm. They're more common during summer and spring, for example in June. Of course, sprites can appear at any time if there are powerful enough storms with lightning at ground level. The skies need to be clear and very dark, ideally without bright moonlight. And the storm should be around 100 to 200 miles away. That way, clouds won't block the sky and you'll have better visibility. In the perfect scenario, the storm will be moving along a distant horizon, so you'll be able to see everything above the cloud tops. You can track a storm with weather radar. Your eyes need some time to adapt to the darkness around you. Give them some time, about 20 to 30 minutes. Keep your eyes above the clouds and try not to look at the clouds directly. Ignore lightning flashes. A sprite will pop maybe once for every 200 lightning strikes. Don't expect to really capture it on camera, it's not easy. But the view itself will likely be worth the wait. This and similar flashy events are something we call TLEs, which stands for Transient Luminous Events. Blue jets are also worth mentioning. These are dim blue lights that stream up like a very fast puff of smoke above powerful hailstorms. They're also very rare, and in most cases, you'll only be able to see them from an airplane. And now we get to those fairy tale creatures. Elves, when we talk about lightning flashes, are brief disks of dim light you can see about 60 miles high in the atmosphere. It's just an abbreviation. Their full name is emissions of light and very low frequency perturbations due to electromagnetic pulse sources. Yeah, I suggest we stick to elves. Moving to trolls. Those are red spots that pop close to cloud tops after the flash of a very powerful red sprite. Gnomes are the smallest and fastest flashes. We're talking about tiny white spikes of light that flash from the top of a big anvil of thunderclouds. The anvil is that elongated cloud you see at the top of a raging storm. It spreads downwind together with upper-level winds, and gnomes last for only a microsecond. And check this out. Ball lightning is in the shape of fiery orbs that can be as big as a golf ball or can grow up to a very large beach ball. They can be yellow, red, white, orange, green, or purple, and they can stay alive for a couple of seconds, even minutes sometimes. Over the centuries, many people have been talking about how they saw ball lightning, sometimes even floating into their homes. But such events are really unpredictable and happen very rarely. Scientists have managed to recreate ball lightning in the lab, or at least something very similar to it. They have realized that ball lightning probably shows up after a lightning bolt strikes the ground. Mineral grains in the soil then vaporize. Here's something spectacular: volcanic lightning. This one is born in the plumes of a wild volcanic eruption. Like the rest of thunderstorms, volcanic lightning forms when static electricity builds up in Earth's atmosphere. And then it gets released in the shape of a lightning bolt. Scientists don't understand the whole mechanism here, but they think it's related to charging. For example, ice charging is what causes thunderstorms to form. It plays a part in producing lightning during volcanic eruptions too. This happens when the air heated in an eruption rises into the sky and meets cold air. The water from the eruption turns into ice particles, and when these particles bump into each other, some electrons get knocked off. The ice particles that now have more positive charges move higher into the sky and gather together. Or it may be frictional charging, another thing that leads to volcanic lightning. The same as ice charging happens when tiny particles of ice collide. Here we have ash and pieces of rock colliding and creating charged ions. There's dark lightning too. Over 10 years ago, researchers discovered that thunderstorms could generate brief but very strong bursts of gamma rays, which is the form of light with the highest energy. They are so bright that they can blind sensors on satellites, even when they're hundreds of miles away. They can also create antimatter. Antimatter is a type of matter made of particles with opposite charges compared to the particles in normal matter. Imagine having two boxes full of blocks. Some blocks are red and some are blue. When these pairs touch each other, they disappear or annihilate and turn into energy. That's what happens when particles of matter and antimatter meet. And these flashes could be the result of dark lightning because it gives off light that's not really visible. Regular lightning involves slow electrons. In dark lightning, electrons are high energy. They crash into air molecules and, by doing that, produce gamma rays.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the US was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So, a derecho is kind of like a small, average level 1 to 2 tornado. Usually, its speed is within the range of 73 to 113 miles per hour. And, in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, Scientists don't have an exact explanation, but although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen. Let's head to the Middle East. There's a large desert here, and it's completely dark, except for one spot. It's a big circle that glows with a bright orange light, the Darvaza crater, and it's just a giant gas burner. Years ago, geologists found gas here, and they started mining for it. But when they excavated, they came across a void underground. The void collapsed, and it formed a crater. It's as wide as half a soccer field, and as deep as a 5-story building. Gas began to come out of the cracks in the crater, and since animals were often grazing near this place, the geologists decided to set these gas streams on fire to exhaust the source. Geologists thought the fire would be over in a day or two, but if you come here now, you'll see this gateway to the underworld is still burning, and it's been going on for almost 50 years. In 2013, a man descended to the bottom of the burning crater for the first time. He collected many different samples there, and scientists were able to find bacteria that aren't found anywhere else on Earth. They're quite comfortable at the bottom of this endless burning frying pan. In 2009, a man in L'Aquila, Italy, saw flickering lights dancing above the stone street. He immediately knew what to do and moved his family to a safer place. Only seconds later, a massive 8.3 magnitude earthquake hit the whole region. His knowledge of the strange lights saved his and his family's lives. So, what are those mysterious warnings? For centuries, people interpreted the lights as something otherworldly. The scientific community didn't take them seriously, just put them down to a false recollection, a mind trick, or pure imagination. With the introduction of surveillance cameras and smartphones, the amount of evidence grew enormously. Now the connection was obvious. Lights appear and an earthquake hits. So, experts finally started taking it seriously and started digging for the truth. But after years of research, to this day, geologists are still not fully sure what the source of the lights is. But they have recognized 5 types of them. Bright flashes that light up the sky, looking like storm lightning or a strong camera flash. Rays in the sky that can look like light columns. Different sized flames that come through the ground. Diffused glows over the mountains. And slow-moving balls of light that can be misinterpreted as ball lightning. Another equally little understood atmospheric phenomenon. These are literal balls of lightning that can float and explode, leaving a sulfuric odor behind. But unlike ball lightning, these spherical EQLs seem to be harmless, if you don't count what's coming afterward. But with all these types of lights, experts can't know how exactly they're connected to earthquakes. They don't only show up before one hits. Some have been reported during and after earthquakes. They can also appear with other phenomena, like meteorite crashes, volcanic eruptions, or auroras. For now, scientists can only come up with theories to explain the unexplainable. One of the recent ones claimed the lights were electric lines being broken during an earthquake. But this theory doesn't explain how the phenomena was observed hundreds or even thousands of years ago. Like the ancient Chinese tale of dragon-looking clouds appearing in the sky as a warning of an upcoming quake. Or how an ancient Roman historian reported huge flame-like lights bursting out just before a huge earthquake occurred. The electric line theory was quickly dismissed. Another theory suggested it was escaping gas. During an earthquake, the underground rocks expand and shrink under pressure and heat. This opens and closes small spaces between them. Different gases make their way through these new openings. Radon, for example, can get released during seismic activity. It can ionize the air, making it electrically charged. But radon doesn't do it enough to create bright sparks of light. This theory is close, but doesn't quite hit the mark. One of the most accepted theories is that it might be from electricity traveling up from underground. When underground igneous rocks, ones that form from magma deep within the earth, are under stress, they release ionized, or electrically charged, oxygen. It travels through the surface and up into the atmosphere, where it creates a localized electric field. That can produce brief flashes of visible light. Some aren't even that quick, and can go on for minutes at a time. So, there you are. You've been driving for hours through the night. You didn't have any chance to sleep, so your mind is hanging by a thread. You stop the car and go out to stretch your limbs. And then, you look up into the sky and see a beautiful sunrise. Whoa, wait! There are 3 suns in the sky! You rub your eyes, but nope. There are still 3 bright stars in the sky. No, our home star hasn't been torn into 3 pieces, nor has it been visited by 2 other stars. This is called a sundog. It occurs mostly during severe frosts. Small ice crystals in the sky bend the light. As a result, you may see 3 bright spots in the sky instead of just 1. This phenomenon is officially called a halo. Usually, it's just a circle around the sun. You can even see a halo at night, too. Just look at a street lamp. and you'll see a bright circle around it. Sometimes, a halo can take on a fancier shape. If there's a lot of ice in the air, the light is warped even more, just like in a room with a dozen mirrors. Then, the halo can take on the shape of a human eye. Because of this phenomenon, a false dawn can occur too. While you're looking at the horizon, the dawn begins, and the edge of the sun appears. A little bit more, and wait, the sun starts to just dissolve in the sky. After a few moments, it's dark again. And only a minute later, the real sun shows its face. It was the same light curvature effect you saw before with the three suns. Only now, the light is curved vertically, not horizontally. And instead of the real sun, its reflection in ice crystals in the sky appeared. And now moving on. This cloud looks like a dinosaur, and this one looks like a cat. And this, whoa, it looks like these clouds are falling down. Oh, phew, that's just a mammatus cloud. Their shape really makes them look like chunks of cloud about to slam on the ground. Well, that's not going to happen, but you better start seeking cover anyway. Such clouds are a sign of a severe thunderstorm coming. It takes a lot of moist air with ice crystals at the top and dry air at the bottom to create such clouds. Then, vertical currents of air appear between these layers. And these currents make the clouds take the shape of a human brain. And this giant cloud looks like a dome that's going to cover an entire city. In fact, that's exactly what happens. A huge cloud covers a large area and then rains heavily on it. Sometimes, the front of such a cloud takes a bizarre shape, like in these pictures. It looks more like several giant spaghetti clouds, or even giant cloud worms. This phenomenon can often be seen in Australia, and it's called morning glory. It happens because a strong wind twists part of the cloud on both sides, and then the huge sheet of air dough splits into thick strips. And sometimes you can see clouds in the sky made of birds. Wow, that cloud moves quickly and changes shape. It becomes more transparent, but then denser and darker again. The birds seem to be involved in some kind of dance or performance, but they're not doing it for beauty or for the crowds of spectators gathered below. They're doing it for protection. When birds group themselves into such a cloud, they intimidate birds of prey. An eagle or hawk would have a hard time picking out a single target among the endless number of birds. And they move quickly, covering each other. Fish are huddled together in schools in the same way. Such a cloud might just spook a hungry predator. Grab some sunglasses and you're good to go. This phenomenon lasts around 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many different ways. J-shaped trees might mean there's a landslide coming. Since the ground is moving slowly, the trees grow into this super selfieable shape. Try to find a flat area and avoid going near any trees unless you have superhuman strength. Another mystical phenomenon can be seen in the desert, a sand waterfall. When the wind brings a lot of sand to the edge of the canyon, it begins to fall down. Now amplify this effect 100 times and you get a sand waterfall in Saudi Arabia. It's really like Niagara Falls, only there's not a drop of water. The locals say this phenomenon warns of an impending sandstorm.